I'm a bit lethal when it comes to using one of these, so if you stop hearing me or if I'm screeching, maybe just make dagger eyes at me. So I'm here today to talk about fairness in AI. And why am I using the word fairness rather than bias? My background is in statistics. We all know bias is something that is just inherent in data, and so I think it's more interesting to frame it as fairness. How do we be fair? So, next slide. I love this quote. It's going to be interesting to see how society deals with artificial intelligence, but it will definitely be cool. And there's the CEO of iRobot, they're responsible for Roomba. Why I like this is the interesting choice of conjunction, but, which sort of implies that the first half is sort of negative and the second half is positive. And I think we're already seeing that over the last few days with ChatGPT. It's super interesting, super exciting to observe, but lots of people are already spotting some potential issues with these newer large language models. So first, an introduction to myself and some motivation as to why we should be interested in this topic. So my name's Gráinne McKnight. I'm from Ireland, hence the somewhat faded accent. My background originally, like I mentioned, was in mathematics and statistics. I then worked for quite some time in fintech, first in N26 here in Berlin, then some time in Adyen in Amsterdam. I worked initially on NLP topics in N26, but I also worked quite a lot in financial crime models. So I really saw a lot where ethics comes into play, because financial crime is something that touches everybody. Every time you use your card with Adyen, it's going through one of the models I built. So hopefully it's making choices ethically. And now I work at Spoke.ai, and we are a small NLP-based startup here in Berlin. We're about 1.5 years old, and we use, among other things, pre-trained large language models. So we're very motivated to stay on top of the trends in NLP fairness and general data ethics. What is fairness? So I think what hopefully should become clear at the end of this is that there is no one definition of fairness. It really depends what you're applying, where you're applying it. But just to give you something to start with, there's this rather long sentence, but an algorithm is said to be fair if its results and performance are independent of given variables, especially those considered sensitive or protected. So these can be gender, ethnicity, nationality, sexual orientation, disability, etc. Next slide, please. So one question. It works? Great. So before we talk about basically look at some examples of where algorithms have been unfair, maybe we can talk about how bias can be introduced. And really, when we talk about fairness, we mean the absence of harmful bias, right? And bias can be introduced in 3 main ways. These are not the only ways, of course. The first is in framing the problem. So when you are trying to build any sort of algorithm, you give it some objective, some problem to solve. And the way we communicate is through mathematics, essentially, through our programming languages. And a lot can get lost in translation. So we'll look at one particular example of where that went wrong. Another can be in data collecting and preparing. So if the data that you collect to train your model on is not representative of reality, so if it underrepresents certain groups, for example, that can lead to harmful bias, or if it reflects existing prejudices, it can reproduce those harmful biases. And related, but its own standalone, is the model you select. So as we move deeper into deep learning, problem we're faced with is really disentangling relationships between certain variables and these protected attributes. So one thing, for example, I saw a lot in financial crime was product managers would come up to me and say, can we please use postcode in our model? And I'd say, no, because postcode is correlated with a lot of protected attributes, such as ethnicity or socioeconomic status. And really what you have to do is build a model that's based on the underlying causal factors. And it's not because you live in a certain postcode that you commit crime. It can be correlated, but that's not the underlying causal factor.
Can I have a question?
Yeah.
So it's about the definition of fairness you have, is because it looks very much like a bias. In fairness cases, you actually can have cases where discrimination is okay. It's something that you want to have.
Yeah, so one tricky or one common place where you could see this, for example, so a lot of people talk about fairness through unawareness, which is if your algorithm doesn't contain a variable, which is a protected attribute, then you're all in the clear. So if your algorithm for financial crime doesn't include gender as a variable, all good. But there are many cases where you can imagine using gender in your algorithm is really important. So for example, for medical tests, it actually can be quite relevant what gender you are in order to produce the best accuracy.
Or access to universities for minorities, for example, where there is actually law that requires that you actually have a preference.
Yeah, I will actually see later on in this presentation, there are different fairness metrics you can use depending on what outcome you want. So the main thing is fairness, your definition of fairness should be in line with your ethics, like what you ultimately want to achieve, which kind of comes back again to this alignment problem. So this is this article and these materials will be shared with you after, and you can follow the link and read it at your own leisure. But this is a specific example of what's called the alignment problem. So this study looked at searches of STEM job postings, and they discovered that they were shown far more often to men than to non-male searchers. And when they looked into why this was, they saw that the algorithms that were deciding which ads to deliver to the end user were optimizing for lowest cost per click-through rate. And it wasn't the case that the click-through rates were different among the males and females. It was actually that females were more expensive to advertise to. And because they were optimizing again for that low cost per click-through rate, they showed it more often to men. So the problem there is not that the algorithm was actually doing something wrong, per se. It was doing what it was told to do. But it didn't maybe match the ultimate goal of whoever is posting this job or serving the job postings. And that's one place where you have to be careful. So here's another example of where data collection can lead to bias. And this is from The Economist. And it's really nice visual. They had a few others. You can go and check them out. But here what you see is Google Open Images dataset. And the resolution's not perfect, but what you can see in these two visuals, the first one is on the left-hand side, images that have male people in them, and on the right, female, and then the associated labels, and then the proportion of labels in those data sets. So you see on the very right-hand side, images labeled marriage are like way, way, way more likely to have female than male images associated with them in this data set. And you can see, for example, in the lower graph that ballet dancers are seen more frequently in images of lighter skinned than darker skinned people. And this, as you can imagine, can lead to problems in model accuracy if this is the data set that you use to train your models. And just one thing on that, like it's not all a story of big companies like Google doing bad things. Google actually recognized this as a problem, and they open sourced a place where you can actually upload images like taken from different geographical areas, exactly trying to correct for this bias. So this is another example of where you can have biases, but not biases, but just unethical behavior associated with data in general, because I'm focusing very much right now on bias in data, but there are many things that can go wrong when building a data product. And recently, as Roe v. Wade was overturned in the US, there was a bit of a panic about period tracking apps and whether or not you should feel safe tracking your period, because maybe then they could find out that you had an abortion. It turns out that that's okay. Like no one is going to get in trouble via their period tracking app. But what is actually true is that a lot of these apps in the US have been fined by the FTC over the last few years for sharing this data with advertisers. So, for example, Flow is one of the biggest ones, and the notes that you take in it, they sold that to advertisers like Walmart's, like Amazon, etc. And that's just, potentially unethical behavior. So it's not just about bias. Okay, so how do you mitigate bias? The first step, I think, is identifying it and measuring it. Another step is being transparent around it, both building transparent models so you can really see where bias is introduced, but also being transparent about which data your model was trained on, whether it could have a propensity to bias, and therefore encouraging users to treat its output in a way like that works with that and it respects that. And a third element is human-centered design, which I will also describe what that is. So how first do we measure bias? So brief review of some binary classification metrics. I'm going to focus on the binary problem here, but of course with multi-classification or other sort of machine learning problems, there are equivalents or near equivalents. So a true positive is when you predict something to be true and is in fact true. The rest you can read. But most of the time when we're training a binary classification model, we're trying to have the highest true positive and the lowest false positive rates, and then the highest true negatives and the lowest false negative rates. So just getting back to this idea of how fairness can be different in different contexts, I want to give you this. You can peruse at your own leisure. I won't go through it in too much detail, but basically these are three different types of fairness. The first one is demographic parity. So this is if people go, or like if samples go through a classification model, the same proportion from each group should end up being predicted true. So in this instance, if you have 20 females and 80 females and 20 males apply, this should be 8 females and 2 males should be offered a position. So that's obviously quite limiting definition of fairness, but that's often what ends being applied in, for example, a college admission process. What you might be more interested in is inequality of opportunity. So assuming that there are certain numbers of qualified males and females, the same proportion of qualified males and qualified females should end up being offered a position. What's even stricter still is this notion of equalized odds, where you have equality of true positive and false positive rate across both protected groups. And you can see that each of these types of fairness might be something you want to apply in different scenarios. So think about cases where you're really optimizing for true positive rate. So when you're detecting a disease, for example, that might be something that you would consider equality of opportunity very important. There are other times where you're really focused on equalized odds. It depends on where and how you're applying your model effectively. And Just one thing to say about this is there is a great tool from Google called the What If tool, and they allow you to look at the Compass data set, which is this data set for this model that was used to predict prisoner recidivism, which is the likelihood of a prisoner recommitting a crime once they were let out. And you could see with that model, it ended up being quite biased towards darker skinned individuals. And you can play around in their tool with different so it was a binary yes, no model. And you can play around with the threshold above which you say yes and below which you say no. And by playing around with that threshold, you get different sort of fairness rates for different protected groups. So you could really optimize it to be more fair across different groups. So I'd recommend you go check that out. So another element I mentioned is human-centered design. What is it? It's basically just keeping the human in the center to whatever you're designing. It's pretty self-explanatory. And one great resource for this is Google's People and AI guidebook. So it's produced by their Pear Research Group. And they really start with this framework for how to build a product and questions you should ask yourself as you're building any sort of product involving data. I personally have found it so useful because often as a data scientist, I skip over a couple of these steps. I just see a problem and I try and solve it using mathematics. And I don't consider when and how should I use AI in my product. I say, oh, AI should be used everywhere. Why not? And I've found this very, very useful. And one thing they really narrow in on is exactly this problem of framing the problem. So how do you translate your user problem you're trying to solve into a problem that you give to your machine learning algorithm, or you then try and solve using data? So the first is finding the intersection of user needs and AI strengths. People get excited about AI. They say, why don't we do this? And sometimes I'm like, but is that actually a problem right now? Or is it not? Assess when to automate and when to augment. So one use of AI that I personally love is Gmail's autocomplete as you're writing your email. It really just suggests what you should write next. It doesn't automate for you. It doesn't send an email directly, which would be a bit scary, in my opinion. It sort of suggests you can easily tab, it completes, it augments your email writing process. And I think there's a lot of AI use cases out there that fail because they try to automate when they should really be augmenting, because there's still a lot of tasks we do that we enjoy and that we want to have a lot of control over. People want to have control in medical situations. It appears they still want a lot of control in driving situations. So it's something always to keep in mind. And designing and evaluate the reward function. So what is a good outcome from your model? It mightn't just be about getting the highest accuracy. It might be also about being fair or not producing harmful content. So with generative AI, so these large language models that are producing text output, it's, for example, maybe not just whether they're good at completing text, like that's one way to score them, but also is the text that they're completing safe, harmful, or harmless, inclusive? Does it satisfy these other ethics we would like to bring to like everything that we produce in products? And then transparency. So I like this definition of transparency in AI because often we leave out the understandable. So we say transparency in AI requires an explanation of how an algorithm works. That explanation also has to be understandable, or else it's not a very useful explanation. And that means answering, what is this algorithm doing? Why is it outputting this particular decision? And how did it know how to do this? And with the EU's new regulation, etc., like this is going to be more and more something you will have to consider from a regulatory point of view. But it's also just important to be able, going back again, able to design really good reward functions. So part of transparency is simplicity. So solving the problem in the simplest way that you can then use an understandable explanation for. There are lots of tools for explainability. Some of them are only applicable to a certain class of models like SHAP and LIME or feature permutation methods. But another way to be transparent with not just people within your team, but broader set of people who might use your models are model cards. And Google, again, have great examples of model cards, and I linked the example there. But you can see it with OpenAI's models, for example. They have extensive documentation explaining what their models were trained on, what are their limitations, what are their performance on certain benchmarks, what are the problems that they have seen with them. And I think this is really great trend, and hopefully it will continue. And just because a lot of that could have sounded like dire warnings, I think it's also very exciting. Of course, all the developments in AI. And also with any problems that arise, it's also an opportunity for more technologies to emerge that help with those problems. And there have been very many over the past few years. So there are a bunch of tools that help you determine whether or not your algorithm is fair, or give you ideas of how to ensure your algorithm is fair. And those include ones from Facebook, Microsoft, the What If tool I mentioned from Google. But beyond that, there are now a lot of startups I've seen that really work with you directly to try and make sure your algorithms are fair. There are these resources and templates for model cards. And there are other sort of not fairness related, but like DataBloom.ai are a cool startup that allowed distributed learning so that you're really not transferring data away from where it's sourced from. And in Europe, what's especially exciting, hopefully, is OpenGPTX, which is a project to build a model an EU equivalent of GPT-3 that will support more diversity in languages. And I guess hopefully be more in line with the EU's regulations. Yeah, so that was it. I'm happy to take any questions you may have. And also feel free to ask me during the break or reach out to me on LinkedIn if you want to have a follow-up discussion about any of this stuff. So, yeah.
I had a question regarding the matrices you showed. The basic doubt was like when you design a model, right? The underground evaluation data, what if that is also biased and your matrices come out good and you just deploy the model with that evaluation data? How do you even think about the variables that's going to affect your model?
Yes, so I think a lot of, I mentioned model cards, but a lot of data sets these days also have data cards describing the data set. And the first step would also, like, of course, to try and make the data set itself as fair as possible. And there are lots of interesting things out there to do it if you can't get fair data, like generating synthetic data, which is fair. You can explore things like over and under sampling certain parts of your data set. But then on the point about like whether you look at this matrix and if it's fair or not, you just go deploy. I think it's the same with model accuracy, for example. You don't look at just accuracy on one data set and deploy and say, see you later, model. Like hopefully you're monitoring it in production. You're constantly doing sense checks on the decisions it's making and building sort of a robust ML infrastructure to make sure you monitor it over time. And the other thing is, of course, I'm sure at some point you may have to retrain it. And then you also, of course, need to make sure the data set then is fair and won't lead to biases. Does that answer your question?
Yeah, like thinking about that variables is kind of difficult. Like maybe if I'm training an age prediction model, there might be a lot of variable that influence it, right? Which I might not even think about while making the data at the initial stage. So
Yeah, no, that's okay. Yeah, that's a really good point. So, like, as an example with like some of the fraud detection models I have built, like, of course, you can try and think in advance, like, how might this lead to harmful bias? Like, one sneaky example I came across from a model that I developed was I was using somehow like the format of email addresses a bit because it could be predictive of fraud. And the reason it could be is a lot of people who commit fraud use throwaway email addresses, and but then I found that penalized a lot against shoppers from a lot of very different regions, because in some regions in the world, like non-fraudulent shoppers may also use those kind of throwaway email addresses. And that was something I hadn't thought of at all up in advance. But I think how we discovered it in the end was doing sort of human spot checks of decisions the model was making and noticing basically, oh, this is a false positive, and what are the trends we see in those false positives, and kind of pulling those out. So yeah, maybe it's just about always human, like some level of human review of decisions from a model where the stakes are quite high, I guess. Yeah.
thank you.
Thanks for the good presentation. I have a small question. So I believe there are models like used right away from Hugging Face. So there's this transparency and the biasness that you spoke about. So, and you also mentioned about publishing that beforehand, which is a very good suggestion. But my point is that there are companies which are using the models as it is off the shelf. I mean, do you have any suggestions for the companies like those? Like, how do they kind of, tune it or correct it, address the fairness and the biasness point?
Yeah, I guess the first step is a bit like, same with eating. Eating ethically is all about where you source your food from as well. It's like maybe building ethical models. If you're building on top of other models, making sure that where you source those models from does have that record of what is the training data and what is what are the dangers. Where that's not possible, I guess the next best thing is to try, if it's not easily available, to try find that information, which in most cases I think it is out there. Maybe it's buried in some academic papers somewhere, and just to see if there are any major red flags. And then the next step again, I guess, is really seeing, and it all depends what the stakes are and what you're doing, right? But if your algorithm is making high stakes decisions or generating high stakes output, then it would be really rolling out that model with a lot of human in the loop aspects to it, like really seeing, kind of going back to this augmenting versus automating. Like if you have an idea of automating something, beginning with augmenting and then learning from human feedback, whether it's your end user or feedback gathered from internal users or whatever, like, I didn't like this output, it was harmful, or, like one thing I've seen in some tools that use in the background, things like GPT-3, is they have a lot of feedback built in, which says, is this output good? Is it bad? Is it harmful? And that's like a third element. So for example, if GPT-3 generates output which has non-inclusive language, then they have a third sort of feedback loop for that. So maybe that's an option. Yeah. Does that answer your question? Yeah, great.
Okay, maybe a bit of a related question. So you spoke about data sets that I would just download, or a model that I would just download. But maybe I'm using my own data, and more often than not, I might not be aware of the biases to look for. Yeah, so nowadays, of course, gender bias or demographic biases might have it made it to people's awareness, but there might be other biases. And would you have an idea, or is there like a checklist of common biases I could look for, a tool that I could throw my data set at, and that would give me a flags, look for this, look for that? That would be cool.
Yes, some of those tools I mentioned, they have sort of a list of what are currently considered protected attributes. The definition I gave in the beginning, it comes from those protected attributes are as per the UN. So what they consider to be the protected attributes. One random example where I have noticed, I'm a left-handed person, and a lot of mobile apps are designed for right-handed people. And there are some that are designed for left-handed people as well, and they have left-handed modes. And that is so cool, right? Like, I think the way to get ahead of these things, like, personally, I survive with the apps that are for right-handed people, but it gives me so much joy when there's a left-handed mode. So maybe it's also seeing out there, what are the people on the cutting edge of like product design? What are the different user groups that they're beginning to build cool features for? Like another one I think a lot of people have started introducing is like the different light in web design, like the different sort of, I don't know what it's called, but like light shades for different screens, and making them screen reader accessible, of course, and all of these things. And that's something where I think there's still lots of questions about like all sorts of difficulties people have with screen reading, with ingesting visual information, etc. How do we account for them in machine learning models as well, in the output we generate from NLP models? So maybe it's also keeping up with those trends, I guess. Does that answer your question? Or?
Yeah, basically you're saying look at your users.
Yeah, I guess. Yeah.
Okay. I'm coming from the side that you didn't expect, but I also want to represent online audience for them not to feel like undervalued. And so I want to ask this question starting from the beginning. Is this possible to automate fairness in the means that can we assess fairness without any human intervention? So can it be just done where automatically counting true positives, false negatives, and boom, it's fair?
So I think, and related to what you were asking, like ethics themselves, like with how we live our life, are not equal, like not shared across everybody, but they're also constantly evolving over time, and we discover new things that we then consider this is an ethic that as a community we want to live by. So I think we need to constantly, if we want to keep humans like in the center of what the ethics of our world should be, humans should always be involved in building and encoding those ethics, I think.